Alright, so let's go ahead and get started. Today we're finishing up 9.4. Watch, we're just going to do the quiz on it because we finished 9.4 already. Two sample means dependent. We're going to do a little bit of review and then we're going to do chapter 10.1 because I think it's better for us to do 10.1 now than for you guys to take a test on Thursday.
Yeah.
Okay, so we'll do that. And then today you have Connect Math 9.3 due and also Lab 7 due. Thursday you have 9.4 due. Your exam will be on next Tuesday covering chapters 7 through 9. I'll do review session tomorrow from 7 to 8, and then on Monday from 12:30 to 1:30 and 6:01. Oh. Yeah. So just a reminder about dependent samples. They're matched pairs. The hardest part about dependent, you guys focus. The hardest part about dependent is figuring out that it is dependent. Right? You see two samples, you just do a two sample thing, and then you get it completely wrong, and you just lost 14 points out of a 100-point exam. Right? That's a grade and a half. So the hardest part about it is figuring out that it is dependent. How do you know it's dependent? Because they'll be matched up. You guys see how they're kind of matched up with, and if you look at the details, it's not the same thing. They're two different things that are, they're kind of labeled. You see that? Where they have some sort of connection. So that's how you know. They're not two random samples of the same thing. They're similar things, but they're sort of the groups have some sort of relationship to each other, and they're matched up. Good? Like specifically one for one. So that's how you tell. And then what you do, that's super easy. Just subtract the first one from the bottom one. Make it 12, 8, 0, 1. And then you run a one sample t-test on these numbers here, on the differences. So you've taken two samples and really made them into one sample. Right? So it's just that one sample t-test on those. And that's super straightforward. The only catches are there's two weird things. Well, one, obviously you have to find your mean and standard deviation yourself by putting them into your calculator and doing into list, right? Put them in list 1 and then do 1 bar stats. Oh, I didn't. Okay, so here's the thing that's really kind of cool. You guys, I was being mad at you this earlier. Stat, when you have weird numbers, which you won't have on the exam, you can do this. Clear, enter. Clear, enter. Put your numbers in here. So your numbers on your quiz were kind of hard numbers, right? 11.42, 8.41, 3.98, 7.37, and so forth. And over here they were 16.69, 9.44, 6.53, 5.58. Now look what happens when I go to list 1, and what do I want? I want the first list minus the second list, right? So I can put in second L1 minus second L2, and then look, it's going to overwrite this whole list. Boom, and put them in there like that.
You showed this at the end of last class.
I did? Okay, good.
Excellent.
So that's kind of the nice thing. It makes it a lot quicker and easier to do this. The catch is, you have to remember that now everything's in list 3 and not in list 1. Make sense? All good? Right? So if you want to, you could go back to list 1, now that you've already used it to get list 3. And you could just put in list 1, what do I want it to be? I want it to be everything's in list 3, right? So I could do second L3, and then boom, now it's exactly the same as list 3. So you can totally do that. Okay? Great. So that's stuff about the lists. So back to dependent. There's two things that are kind of weird about dependence. One is that the H0 and the H1 is all about the differences. So think of it like mu1 minus mu2 is what? Is it going to be greater than? So if you're saying that the first one is bigger than the last one, they're saying that the mu d, the differences, is greater than 0. If you're saying when you subtract those that the first one is smaller than the second one, then you're going to say that mu d, the differences, is going to be less than 0. And if you're saying the same, then you'd say that the mu d is equal to 0. Make sense? So that's the one thing that's a little bit weird. You got to remember that it's all about mu d, with the first one minus the second one. So if the first one minus the second one is first one's larger than the second one, then you'd say mu d is greater than 0. First one's less than the second one, mu d is less than 0. So that's the thing, is that your mu, we're always saying that your mu naught is 0. Only in this case, not in regular t-tests. So don't go back to chapter 8 and on your regular t-test, if it says, well, the average height of min is 65 inches, and then do a test and use 0 for your mu naught there. You guys know what I'm saying? We're not saying that the t-test is always where mu naught is 0. Only in this specific weird case. Does everybody understand that? The differences are 0. When you're subtracting two means or subtracting two proportions, that's when we say that the differences are 0. Okay. Or the mu naught is 0.
So then we have to use the list.
Yeah, here you'll have to use the list to find your mean and standard deviation. So you put this into your list and then you do stat calc 1 bar stats on wherever you put this list 3 or list 1, to find your mean and your standard deviation. Please remember, your standard deviation is not mu naught. So if I go to this is going to be slightly different than yours, and I do stat calc 1 bar stats list 1, because I copied over list 1, so I'm okay, I just hit enter. It'll give me my mean. It's going to be different than yours because I only did 4 of them, right? It'll give me SX, which is what you want, the sample standard deviation, because this is a sample. This is not the whole population. Right? This is not every single bank in the world, what they were 3 years ago, what they are today. And it's also going to see what it gives you sigma x as well. It doesn't know whether you gave it a whole population or just a sample. You know that. That's why I gave you both, so you can choose which one it is. Right? You know it's SX and not sigma x. Yeah, Carla.
So these specific problems, are these always going to be a mean?
Yes.
They're always
Great question. Why? Because you have to subtract the differences. If your sample is yeses and nos, how do you subtract a yes from a no?
Yeah, okay.
So they always have to be means. Yeah, good question. Great, thanks for asking that. Right, so that makes it a lot easier, because then you know it's a mean, and you know it's going to be which table, a Z table or T table? T table. Mean Mr. T, T table. And then you're going to have N is what? N is, well, in this case it's 5, right? So you do N minus 1. Your case is a little bit different.
Yeah.
Great. So the different things here are that H naught is always going to be that mu d is equal to 0. So in other words, mu naught is 0 for dependent. 2 dependent means only, right? Don't go thinking it's always 0 for, well, it's for 2, anytime you have 2, basically. But don't go thinking that falls true for all t-tests, because people start falling into that. They started doing an old one and they got all confused because this one is the last one under memory, right? So you forget all the stuff that came before and you focus on the last one. The other thing is, okay, maybe I'll write out what they could be. So here, H1 is that mu naught, mu d is greater than 0. Right, so this is where mu1 is greater than mu2. Or mu d is less than 0. So that's when,
Or not equal to.
yep, that's when mu1 is less than mu2. Or like you said, mu d is not equal to 0. And that's when mu1 is not equal to mu2. Good deal. So then that makes everything else pretty straightforward. Here are some of the things you need to find. Do this. I like to think of this as x bar d, right? instead, but same thing, D is your differences. You have your mu D, which is always equal to 0. You have your X bar D, your sample of the differences, sample mean of the differences, standard deviation of the differences, and N, the number of those you have. And then you'll throw it into here. Remembering that this is always equal to 0 in this particular case when you have two matched pairs. Alright, everything else stays exactly the same. Step 2 stays the same, step 4 stays the same, step 5 stays the same. So the only thing that's different is the H naught's different, right? And step 3 is slightly different. It's pretty much the same, only your mu D is 0 in this weird case. So I'm going to give you guys 2 more minutes to work on the quiz, and then we'll go ahead and start in everything else.